I'd like to spend a few minutes here looking at subnetting. Now that you've been able to identify the network address, the broadcast address, the first and last IP address, subnetting actually should be pretty much straightforward. What we do in the subnetting world is manipulate the subnet mask, which, as you now know, defines the number of bits, the length of the network address, to modify the network address. Subnetting is actually breaking a larger network into a smaller number of networks that we can then route. One might say, why do I want to subnet? Well, in this particular scenario, you'll see that we have 1, 2, 3, 4, 5 routers. To connect one router to the other actually requires only 2 IP addresses, and in this one we're set up with that. So we would need 2 IP addresses between each of the 5 routers, 1, 2, 3, 4 connections between them. If we weren't able to subnet, we'd have to use an entire Class C network, which is the smallest that we get, in order to connect these networks together. By being able to break the networks into smaller pieces, we can then take a single Class C network, break it down into much smaller pieces, and use only the 2 required addresses between each router in order to create the connections. That way we conserve IP address. Have a little check sheet that you might want to use on the Moodle board, which is when you want to subnet a classful network, and that's the reason that we needed to learn the classes of the networks, because we start out with a classful network and modify the subnet mask from the classful network. What we need to know is the number of subnets, or the number of hosts, that we want on our new network, our subnetted network. That's the only 2 things that you can know, and we've used the formula 2 to the n minus 2. You know what bits are, where n is the number of bits that we have in either the in either the network address in the subnet or in the hosts. So again, write it in binary. If you don't write it in binary, you're going to be absolutely totally lost. Now that we know what's required, we must determine the number of bits required to produce the required result. To do this, 2 to the n minus 2. For example, if you needed to subnet a network with 6 subnets, you would need 2 to the n minus 2 greater than or equal to 6. When you solve it, we have n equals 3, 2 to the third is 8, 8 minus 2 is 6, which gives us 6 usable networks. We can't use the all zeros or the all ones, again, just like we couldn't in the hosts. We can't in the network address, the subnet address, or in the host address. And those rules are down here. Subnetting rules are a few, must be applied. The network address nor the subnet address may be all zeros or all ones. The network address is going to be the base network, the one we started out with, the classful network. I'll show you an example here in a minute, and then we'll go to the subnetting worksheet and try to work out a problem. The address that has the all ones in the host positions, zeros in the subnet mask, is the broadcast address, and the one that has all ones in the subnet ID is called the broadcast subnet. It's not usable. The all zeros is the zero subnet, and it's not usable. An example of this is right here, and again, this is on your Moodle page. If I take a Class C network 192.168.1.0 and we want to get 6 subnets like we said in the earlier page, then we would take this classful Class C subnet with a 255.255.255.0 subnet mask, and then extend the subnet mask to the right. The orange here, again right here, it says the orange represents the subnet mask of the classful network. The green represents the network address in binary, the 192.168.1.0. The red is the host addresses. The host address is all zeros. It represents the network address. In this one we have all zeros in the host, so this is the network address. Now we want to determine the number of bits required to solve this assignment. Subnet into 6 separate subnets using 2 to the n minus 2 greater than or equal to 6. The solution is 3. 2 to the third minus 2 is equal to 6. So we're going to use 3 bits, and the 3 bits are represented down here by the blue. So we have extended our subnet mask from 255.255.255.0 to 255.255.255.224, and we have 3 bits, 2 to the third, 8 minus 2, which gives us 6 usable subnets, because again we can't use the all zero subnet and we can't use the all ones. This one right here would again represent the 0 subnet. When we do this, we take the 3 bits out for the subnet. That leaves now 5 bits for the host address. Using the 2 to the n minus 2 process, where n is the number of bits, 5 bits for the host leaves us 30 usable hosts. 2, 4, 8, 16, 32, the 5 bits minus 2, 30 usable addresses. Again, the all zeros in the host position and the all ones in the host position are not usable. We can go down and we'll scroll down this thing and increment the network addresses. The first one is going to be 001, and then we add 1 each time. 1 is 0. Carry the 1. 1 and 0 is 1. So 0, 1, 0. Add 1. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. And then the broadcast subnet 111, which again is not usable. So you can't use the all zeros or the all ones in either the network, the base network, the subnet, nor in the host position. Let's take a look at something that should be familiar on the subnetting worksheet. The address 10.1.1.0, which is simply an address on a Class A network, which has a subnet mask of 255.0.0.0. The subnet or the network that we're talking about here is still going to be the same. The subnet's going to be 10.0.0.0, the 10 network. The first usable address when we do the ANDing will be 10.0.0.1. The last usable address will be 10.255.255.254. The broadcast 10.255.255.255. Let's say that we want to break this network up so that we have, I don't know, let's say 2, 4, 8, 16. Let's say that so that we have 14 usable addresses. Using the 2 to the n minus 2, we need to then go in and add, see if we can change the color here. We need to add 4 bits, right? 2, 4, 8, 16, 1, 1. That didn't work out real well, did it? 1, 1. Well, since that didn't work, let's go in and shade this, or try to shade this with the borders and shading. Let's say that we want to make the subnet mask red. So we've shaded the subnetted portion red, the 4 ones that we added. The remainder of the subnet mask will be zeros because we have not affected that. So our new subnet mask is going to be 255.192.224.240.0.0. So the subnet is going to change here a little bit because we're going to have zeros and ones in here. The first one, the 0 subnet, is obviously going to be the same, because when we AND the zeros, when we get it here with the ones, the first one is going to be 0, 0, 0, 0, 0, 0, the network address. The next network address will be 0, 0, 0, 1. Whoops. 1. Which hopefully you can see that, well, this is going to again be the first one. The numbers don't line up, 1, 2, 3, 4, which is going to be the 16 network. The next usable network, adding 1, will be a 0, 0, 1, 0. And the next one will be 0, 0, 1, 1. We can continue this progression until we have filled up all 4 bits in the subnet mask. We now have 3 different things to deal with. We've got the base network, the original network, which is the Class A network, 10.0.0.0 with a 255.0.0.0 subnet mask. We have the host bits, which in this one were the last, in the base network were the last 3 octets. In the subnetted we have half of the second octet, and the last 2 octets are host addresses. If we continue on with these, we'll get the remaining available subnets as we go through those, and you can continue those. So we have created networked subnets that have fewer hosts, because we have fewer bits for the hosts, but now we have networked, subnetted networks. And you have to again pay attention to the base network, the subnet ID, which is the number that's down here that we create under the subnet mask, and the host address. I think what I'd like to do, I'm back to the blank worksheet, is kind of work on that one that I showed you early on to connect the routers together. 192, 168, it doesn't really matter, 192.168.100.0 network, and we only need 2 bits because we need 2 hosts, 2 to the n, 2 to the 4th minus 2 is going to give us 2. So we would only need the last 2 bits as part of the subnet mask as the hosts. So then we would add 1s to all the other positions in the subnet mask. Hopefully you've noticed through all of this stuff that the only octet that we actually have to do any real changes on, any modifications, is the one we're actually changing. I went ahead and put these in because the computer's being funny trying to run the recording software and Word at the same time. So we now have 1, 2, 3, 4, 5, 6 bits in the subnet mask, which gives us 2, 4, 8, 16, 32, 64 minus 2 are 62 subnets. So when we go into this thing, let me stop this a second and then unshade it. Okay, having shaded these things, the original subnet mask is in the blue. The subnetted network mask is in the yellow, and the hosts are in the purple. Using the same progression, we go through this thing. We have a 0, 0, 0, 0, 0, 1, which is going to give us the number shifted a little bit. 1, 2, 4. The first one obviously is going to be all zeros, which again won't be usable. All zeros in the subnet, 0, 0, 5 zeros, 6 zeros, and then the 0 in the host. That won't be usable. The next one will be 1, 2, 4. The next one will be 1, 2, would be 1, 0, which would be 1, 2, 4, 8. 8 and 4 is 12. So if you'll notice that we do have a progression as we go up 0, 4, 8, 12, 16, 20, 24, on and on and on. We can now take those subnetted networks, 192, 168, I used 100, 1 would be easier obviously to write the number, dot 4 would be the first network, dot 400,100 would be the network address, so the first usable address would be 101.4 plus 1, 5, the next one 410.6, the next one, the 411, would be the broadcast 7, and then we would go on to the next network. So we have now subnetted a Class C network so that we have 2 hosts on each of the networks. Note that we do lose a lot of addresses when we do this, because we're going to lose half of the addresses every time. We have 2 usable addresses, a network address, and a broadcast address. I think the only other thing to do on this is practice, and there are practice exercises on the Moodle site. So if you'll go through those things, if you have questions, please ask, do the practice, write the binary. But subnetting is just, again, simply a matter of extending the subnet mask to the right, so that we extend the network address and reduce the number of bits that are available in the hosts. Thank you for watching. I hope this has been useful.